Okay, so this video is just running through the first set of examples looking at recurrence relations. The first one that we've got here, write down the first 5 terms of the sequence defined by the recurrence relation below and show the values of the first 4 iterations. So it's important to remember when you have to write down any of the recurrence relation values, you should actually be writing out the steps. Okay, so here we always want to start with V0. We want to state that even though it's given as part of the question. V1, according to the rule, will be the previous term minus 4. So 9 minus 4 will give us 5. V2, so again, the previous term, 5 minus 4 is 1. V3, previous term, 1 minus 4 gives us negative 3. And then V4 is previous term, negative 3 minus 4 gives you negative 7. And so therefore our first 4 iterations, so 4 applications of the rule, so 9, 5, 1, negative 3, negative 7. Okay, so this next example is one using a calculator to generate a sequence. So we'll run through how to do that again, but just quickly, we've got a sequence generated by the recurrence relation where V0, so the initial term is 300, and each subsequent term is 0.15 times the current term minus 9. Okay, so when we jump across to our calculator, we just want a normal calculator page, not Scratchpad, just in our normal calc. And so the first thing that we do is put in the initial value. So V0 was 300 and press enter. And now we're going to pick up our answer, so using second and the minus sign there as the Vn. So literally typing as the rule says, we've got 0.5 times our previous answer. So control minus to pick that up and then take away 9. So when we press enter, that will automatically give us the next term in the sequence, 141, the next term again. So the question's asking us, use your calculator to generate the sequence and determine how many terms of the sequence are positive. So that is 1 iteration, we've got 2, 3, so it's actually this is the first term, 300. So we've got 4 terms so far, 5, 6. So 5 terms are positive, the 6th is negative. And so coming back to the question here to write our answer, we wanted to write down what the sequence was. So 300, 141, 61.5, 21.75, 1.875, and then negative 8.0625. So therefore we have 5 positive terms. Okay, next example, we're jumping to some depreciation. So a bit of little revision here. Remember, depreciation, we have an object that is losing value over time. In this case, we're looking at unit cost, so it's per use of that item. So here we have a lawnmower where V0, so the initial value of the lawnmower was $270. The value after each subsequent use is given by Vn plus 1 equals Vn minus 3.5. So effectively that's saying it will depreciate by $3.50 for every time it is used. So for question part A, we're looking at use the model to determine the value after it has been used 3 times. So that's saying that we want to find the value after 3 uses, so V3. It doesn't say that you have to work through each individual step, so we can jump to our calculator to work that out. And we'll also, while we're there, find part B. So how many times can we use it? So what term before the mower has depreciated to less than $250. So what term will be less than, so really we should write that as less than 250. Okay, so we'll pop to our calculator to work both of those out. Okay, so part A, where we're trying to find out the value after 3 uses. So again, put in our first value, so 270 was our initial, and then to pick up what the rule is saying, so our answer minus 3.5 or 3.50, $3.50. So after 1 use, 2 and 3, so after 3 uses, our lawnmower is valued at $259.50. So how long before it's worth less than 250? So again, we've used it 3 times already. If we keep pressing enter, so that'll be 4 times, 5 times, 6 times. Okay, so after 6 uses, it's below 250. So how many times before that? 5 times. Okay, so just popping our answers to the questions there. So for part A, we said after 3 uses, our lawnmower, $259.50. Part B, when you have to stipulate when something is, or prove that you found when it is depreciated less than that value, and you're not using an equation as such, you're just using your calculator, you can give some evidence as V6 is 249, V5 was 252.50. Okay, so you're giving that additional information to show that you actually did work it out. V5, so 5 uses versus V6, 6 uses. Okay, the next example. So now we're moving into some work with compound interest. So a key thing that we need to remember here is when we're just looking at this compound interest, either investment or loans, our general rule or our key recurrence relation that we're dealing with. So we're always looking at V0 being the initial amount. Okay, Vn plus 1 will be R, big R, times Vn. And the key thing to remember here is our big R, in the case of an investment, we're doing 1 plus our interest rate over any compounding periods over 100. So that's our key little piece of information, is this here. So we can see we've got $2,000 as our initial amount, and we've got an interest rate of 7.5% per annum. So when it just says per annum, that means it's compounding one time per year. And so we can see here their big R value will have been found by 1 plus 7.5 over 100, so 1.075. Okay, so part A, use the recurrence relation to find the value of the investment after 1, 2 and 3 years. So again, we can do that in our calculator. Part B, the value when it will first exceed 2,500. Again, very similar to the last example we did in our calculator. And then writing down a recurrence relation if $1,500 was invested at a compound interest rate of 0.6% per annum. So we'll pop to our calculator to do the first 2 and then come back and do part C. Okay, so for part A and B, we're going to put in our value. So again, $2,000 was our initial amount, and press enter. And then picking up the rule, so 1.075 times our answer, and hit enter. So after 1 year, after 2, and after 3, when we're giving our answer for 3 years, we will round that to 2 decimal places, always 2 decimal places with dollar amounts. So we'll have $2,484.59. Okay, we'll continue here. So at the moment we've done 3 years. So when will it first exceed 2,500? So that's 4. So 4 years was enough to get us over that value there. Okay, so writing down just our answers for A, we had after 1, so sorry, we should put V1, gives us 2150, V2, our value 2,311.25, V3, we've got 2484.59. When will it first exceed 2,500. So after 4 years. Now, part C, we're now wanting to write a recurrence relation. So key information, our initial value is 1,500 and we have an interest rate of 6% per annum. So first thing that we need to do is calculate what is our big R value. So 1 plus the 6% per year over 100 will give us 1.06. So now when we write our rule, our initial value, so we always must write our initial value, and then the next year will be given by 1.06 times the current value. Okay, our next example is another one of just writing rules this time. So again, compound interest, but this time our compounding periods are changing. So Brian borrows $5,000 from the bank, so there's our initial value of 5,000, and he'll pay an interest rate of 4.8% per annum. The difference here though is what happens if the interest is compounded yearly versus quarterly versus monthly. And so again, each time we're working with our our recurrence relation of Vn plus 1 is R times Vn. Remembering R in this case is 1 plus our interest rate over the compounding periods over 100. So our first step each time is to identify that capital R value so that then we can put it into the rule. Okay, so first up with our yearly value, fairly straightforward. R1 plus 4.8 over 100, and so that will be 1.048. So putting that together, remember each time we must write V0 is our 5,000 and Vn plus 1 is 1.048, or our R value, times Vn. Okay, quarterly, so we repeat the same process. Find our big R value, 1 plus 4.8 divided by 4. So remember, quarterly means it's happening 4 times a year. And then put that together. So sorry, our R value will be 1.012. And then putting that together, so V0, $5,000. Vn plus 1 is 1.012 times our current value. And finally, monthly, so 12 times a year, means when we're finding our R value, 1 plus 4.8 divided by 12 all over 100. And so R is 1.004. Putting that together, our initial value, $5,000, and Vn plus 1 is 1.004 times current value, Vn. Okay, that's it for these examples of recurrence relations. What you should be able to work through now is the additional worksheet based on just some general rule stuff. Good luck.